Now let's do fundamental problem 616. Right, so basically now you have two members. Okay, the first one is this L shape BC, right, and then one is AB, right, and then you apply the load. A load is applied 400 Newton downwards. Okay, here with these distances, and a couple moment of 800 Newton meter is applied at this joint, this point. Sorry. And then you have these dimensions, right? So the question asks to find what are the reactions at point C, which is this. They are horizontal and vertical, same like before. Okay, so you have to find what is the Cx basically, and what is your Cy. Right? Here, because the question asks you to specifically find Cx and Cy, actually you don't have to find, for instance, this reaction there over there. Although actually in the process you will find that. Okay. Okay. Now, actually, if you can do highway, long way, or you can, if you understand that actually AB, member AB is a two force member, okay, this is two force member, then actually it will be simpler, right? Same like what we have done before. So when you realize that actually this AB is a two force member, then you can simply draw free body diagram for member BC, which is this BC. Okay, what happened at BC? Sharp edge. Okay, so you have 400 Newton load. Okay, right, and then you have 800 Newton meter couple moment. Isn't it 800 Newton meter? Right, and then here what happened at B? This is C. This is B. What happened at B? What happened at B? You have the B. So here at B, you have this FAB. Simple as that. Because AB is a two force member. So basically FAB will have the reaction of this going through the, along the line, along the member, right? Between the joints, which means that between the joints. Okay, FAB. So after you. Okay, this is fine, but how about the direction, the angle? It's not given. Actually, you can find the angle, right? But in this case, I don't want to find the angle. I just want to use the given distances, which is this is 1, isn't it? 1 meter. Okay, it should be like meter. It's fine. 1 meter. What is this? 2 plus 1, isn't it? So 3. Okay. If this is 1, this is 3, then this is root 1 squared plus 3 squared, 9 plus 1, 10, root 10. Alright? Okay, now I know the direction of FB. So what happened? Next, what happened at C? Okay, so you have Cx. Okay, and of course you have Cy. Right? So these two are the one that you want to find. Okay. But of course, in the process, we need to find FAB as well, because otherwise you cannot find Cx. Or actually, we can do that, but okay, that's fine. Alright, so to find Cx and Cy, what you can do, you can do a couple of stuff, but for instance, you want to find FAB first, then you do the summation. Summation of moment about point C equals to 0, right? So that we will eliminate Cx and Cy for a while. So you have FAB, the y component of it, the vertical component of 1 over root 10. So FAB, okay, positive moment, means positive moment. FAB 1 over root 10, right? Okay, times the total distance, which is 3, isn't it? To find the moment about of this FAB, the y component of it, the vertical component of it, with respect to point C. And there's another one, which is this FAB with the horizontal component, which is plus FAB 3 over root 10, which is this is the horizontal component. Okay, so it does clockwise rotation as well. So we take this arm, which is 1 meter, right? Next, you take this 800 minus 800, right? Because it goes counterclockwise, because we assume clockwise is positive. And then you have this 400. which goes again counterclockwise, which is minus 400 Newton times what is the length? It is 2 Newton equals to 0. So you can see that this equation, you just have FAB as the unknown. Okay, so you can solve the FAB, and you will get your FAB as 843.27 Newton. Right? You have your FAB. Now you can find Cx, right? So to find Cx, you do Fx equal to 0. Right? I think now just have to remove this. Okay? You will do Fx equal to 0. Right? And then you have the Cx, positive Cx. Okay? Let's assume to the right as positive. And minus FAB, which is 843.27. The horizontal component of it is 3 over 10. Root 10, sorry, equals to 0. So your Cx is 800. Right? And of course, to find Cy, you can do summation of forces in y direction to 0, or actually you can do, if you want, you can do moment about B as well. I mean, whatever, doesn't matter. Or even more this point, right? So you have Cy because you assume Cy as positive upwards, okay, and then minus 400, right? And plus FAB, which is 843.27 times 1 over root 10. Okay, you take the vertical component of FAB equals to 0. So you solve for Cy, then you will get your Cy as 133. Right? So this is Cx and Cy. Of course, you have Cx and Cy. You can find the resultant, right? The resultant. You do Cx squared plus Cy squared, root of that, and then you can find the angle, given angle, direction of the reaction. Okay.